Hello, good morning to all. My name is Miguel Cerqueira. I'm here to to give a class in advanced food packaging. First of all, I want to thank the invitation to be here and to share some ideas of regarding food packaging and also some of the work that I've been developing during the last years. Um, to talk a little bit about me, I'm Portuguese. I did my graduation in the University of Minho in chemical and biological engineering that I finished in 2005. Then I moved to 1 year to Brazil for a scholarship, and then I come back to Portugal where I did my PhD in topic related to edible packaging and edible films and coatings. I finished in 2011, and then I did my postdoc in nanotechnology applications for food systems. Then in 2016, I moved to the International Iberian Nanotechnology Laboratory that I'm working right now, where I am staff researcher and where I continue to work in these kind of applications and where we have some of the interesting technologies that we can move further in this topic so interesting that is food packaging. So I hope you enjoy. Today I will give two classes. So in fact is one class related to advanced food packaging that I divided in two parts. Today I will talk about I have a more small part about advanced food packaging, and then tomorrow I will give the other part a little bit bigger, 1 hour, around 2 hours of classes. So I hope you enjoy, and then if you have some questions, I'll be available to answer and to to uh, clarify any kind of doubts that you can have. So I'll hide here my camera. And so what are the learning objectives for the class? So what is important for me, and I think is important as well for you, understand the reasons why packaging is important in the food industry. I think is common sense, but could be important to remind some of these points. Identify the main advantages of using packaging on food. Identify the materials and process technologies used in food packaging. Identify common examples. Recall emerging food packaging systems that we'll talk tomorrow. And identify the most suitable advanced packaging systems for different applications. So we also talk about this tomorrow. For today, I will go to the definitions of packaging, packaging functions, different packaging levels, and some of the packaging materials. In the end, I will share with you um, one publication, is a review paper that was published in 2007, but I think that still is very complete, and I think that you can, if you want to go deep in some of these definitions and the important materials and levels of packaging, you can have a read. But in the end, I will share and I will indicate some books that you can try to find, or there are a lot of publications or books and book chapters about the topic if you want to go deep in some of the things that I will talk today. So food industry and why food packaging. So is a lot of people are talking about packaging, mostly about plastics, about the problems of packaging based on plastics because of sustainability and of all the plastics and microplastics that you can have on oceans and that are not totally recovered after use. But packaging was a game changer in food industry. So in the last 50 years, the way that we buy things and the way that the food industry were able to increase the shelf life of some of the products and use individual packaging to go to the consumers and sold individual and low amounts of products was one of the most important game changers or important things that packaging allow us. So packaging is used since centuries, but this new technology and the plastics and also other materials that I will talk today were very important to um, allow industry and consumers change the way they are consuming and eating and buying foods. So right now you can see that when you go to supermarket or you buy something, they are all packed. So this is one of the things that we are seeing right now and that you can look in the market. So what is the definition of package? There are different definitions depending of the you can see in the some websites or some associations and also some books. I bring you some of these definitions. One of them say that is a coordinated system of preparing goods for transportation, distribution, storage, and end use. Others say that's a way to ensure the shipment of the product to the final consumer in optional conditions and at a low cost. So in the first case, you have distribution, storage, and the end use. In the second, you already have the low cost associated. And then the other art, science, and technology to prepare products for transportation and sale. The Packaging Institute International defines packaging as the enclosure of products in terms of package in a rapid pouch, bag, box, cup, tray, can, tube, bottle, or other container form to perform one or more of the following functions. So containment, protection, preservation, communication, utility, and performance. If the device or container perform one or more of these functions, it was considered a package. So when you think a package, you are thinking of the thing that you go, the glass or the tin or the plastic that you buy when you go to buy something in the supermarket. But there are a lot of things, primary packaging, secondary packaging, tertiary packaging that are important in the food industry that are very used for these functionalities that are presented here. So these are the main functions. So protect, preserve, inform, convenient to the consumers, and in fact allow us to transport foods from different parts of the world and they change the way that we are making distribution of foods among different countries and among different regions. So so they give us physical and mechanical protection. So you have a container, you are able to protect from different things: water, oxygen, the microorganisms. Also, someone is moving the box, if it's closed, you are sure that they are protected. So is able to maintain the quality and safety of the products, increasing their shelf life and increasing the loss of the products. Are able to control the presence of humidity, oxygen, light, and acts as a barrier to microorganisms that can be in the environment. So the packaging is in fact very important also because can be a part of the preparation process. So some of the foods that you buy are processed already with the packaging, or because they are doing a thermal treatment already with the packaging, or if there are some treatment that where packaging is already included. If you have a carbonization of some drinks, already can already do that inside of the packaging. So because you have thermal processing, so it should be hermetic, should be resistant to process temperature, should allow volume changes of the product during the process. So you can have different products that can change this volume, and also allow this aseptic packaging. So in some products, the packaging is sterilized and allow us to add also sterilized products with packaging in the way to maintain their safety of the products. but also because this sterilization process allows the process product filling and closing in perfectly aseptic conditions. So these are as some of the points that should be guaranteed using the packaging for the preservation. One of the most interesting technologies that have been used in the last years is vacuum and modified atmospheric packaging. They use different atmospheric conditions to maintain the food quality and safety. In case of vacuum, you remove all the, the gases inside the packaging, the vacuum, and in the modified atmospheric packaging, you have different mixtures of gases, so you can reduce oxygen to avoid the microbial growth, and then incorporate carbon dioxide and nitrogen. Normally, you will leave some oxygen, very low amount, to avoid anaerobic growth of also microorganisms. So also, most of preservation is also carried under cooling, and in this case, the vacuum and map packaging, we need very specific machines with control and selective permeability, which allows to maintain the gas atmosphere inside the packaging constant proportion or within certain limits of different gases. I will show some of machines tomorrow of this kind of packaging, but only to understand that this kind of systems is mostly applied for high value products because it's a little bit expensive, so the prices are decreasing, but you can see this on meat products, mostly meat products or other products that have a high value in the market. Other of the functions of the packaging that is very, very important is information and service. So information about distribution, seal, instructions of to the final user. So when you buy something, you always have information in your packaging, um, how you can use it, the nutrients, the ingredients, if I have some allergens. So it's very important the way that packaging is giving information to the consumers. And also they can say what, who, how, when, how much. So you can all have this all information on the package. So and also because the packaging uses us for marketing. So the size, the design, and the colors are very important for the industry because consumers are motivated to buy because of that. So it is a very interesting topic. This is not so related with functionality when you think about the preservation, but is mostly related with the information that this packaging can give. Is also very important because can give us not for the consumer but for the distributor the information about the origin of the packaging of the foods, the suppliers, the shelf life, and so on. So the date, the due date, and so on. So it's very, very important the information that packaging can give us. So and can help the consumer to choose. So the name of the food is very important. The way, the metrics, list of ingredients, how the food should be stored, the date when the food should be eaten, modified ingredients or allergens, and name of the address of manufacturer or distributor, and nutrition information. There are very specific uh, laws about this. So each country have their own. So you should follow the regulatory advices of most of the countries for this information on the packaging. Um, so can provide extra information, cooking, the place foods comes, and you can have a barcode to identified food. In fact, I will talk tomorrow about intelligent packaging, and one of the things that intelligent packaging can help us is with this kind of information like a barcode or another kind of device that right now everyone has a smartphone and can go there and have more information than the one that is in the packaging. So right now there are a lot of companies and products that you have additional information. using your smartphone or internet. So you go there and you have something that gives you a link or a connection for the information that you can have or the company want to give to you. So the design, as I mentioned, is very important. Style. You normally, when you look for a packaging, I can give you this example. So if you, in your right, you can see these kind of bottles, like a handmade product, and the packaging give you this kind of information. And when you see a plastic or something more um, uh, without this kind of design, you can see, no, this is processed food, ultra processing. I prefer handmade. So this kind of the way that the companies are changing or design the packaging are the most important for the consumers right now. So mostly there are studies on that show that some of the consumers choose by the packaging and not for the nutritional aspects or because of the brand or so on. So these are more for to preserve, to protect, to inform, and to transport. Are the main functions of the packaging. Um, these functions are also related with levels. So we can define three kind of levels in the packaging: primary packaging, secondary packaging, and tertiary packaging. The primary packaging is the one that is in contact with the food and is usually responsible for the maintenance and containment of the product. Most of the studies and some of the work that I'm doing and we are doing at INL is related with primary packaging. So in this case, we need to be very careful with the materials that we are using as a food contact material. The legislation is very strict on that. But is also one of that gives you more opportunity to innovate and give some solutions to the industry, because are these primary packaging that will affect the shelf life of foods. Then you have the secondary packaging, such as cardboard boxes or cardboard. Mostly they are paper based, that are able to contain one or more primary packaging. So it's a way for transportation mostly of the primary packaging. Can be paper based, but also there are of plastic. Right now there are a lot of secondary packaging based on plastic, and then you have can call it transit packaging. That is the tertiary packaging that contains the primary and secondary packaging for shipping. So the choices of this type of packaging depends on natural individual packaging, if it's rigid, semi-rigid, or flexible, type of pelletizing scheme that you are using, and the cost. So this is very important as well, because since right now a lot of products are being moved for other countries, and they have to go through a lot of time during this process, and because the price of transportation is based on weight and also volume, the way that you are putting all together is very important. So the way is important because if you are using glass or plastic will be cheaper, and also because if you have different packagings that can be all together without voids, without empty space, will reduce the volume. I can give you the example of wine bottles that are cylindric, and they have a lot of, when they are put it together, they have a lot of air, so a lot of space, and so the volume of the wine bottles is very big, and is also very the way when they are using glass is also very high. So the price for wine bottles to be shipped is very very high. So one of the things and one of the innovations with the design is I don't remember right now the name, but is a company from UK that develop a bottle is based on is plastic base, but is flat and is not cylindric. So they are able to put all together without voids, without air between all the bottles. So they are winning a lot of awards based on that. You can think, no, it's very simple, but they they do that, and they change the way that the wine that's being sold. I don't remember right now the name, but I can, if you have curiosity, you can send me an email and then try to remember. So regarding the classification, food packaging can be based on different materials: glass, metal, plastic, or paper, wood, textiles, or cork. So you can focus mostly in glass, metal, plastic, or paper, and then you have some materials that's like cork that are using bottles, or some wood or textiles that are mostly used in as a design or secondary packaging. But glass, metal, plastic, or and paper are very used by the industry, depending on the application. I'll talk a little bit about these materials in some minutes. So the packaging can be classified as rigid, flexible, semi-rigid, and they can be monomaterial and complex and multi-layer. So this is very important because the the requirements for depending of the foods and when you go to the industry and you are trying to present some of the products that are developing, they have a very specific requirements. So if you want a rigid material and you want to go to plastics, only few plastics have this capability. But if you want a flexible, uh, you cannot go to glass, and metal is very difficult, and paper is very difficult. So only plastic can give you this capability. So the requirements is mostly given by the companies, and you can adjust according with the with the materials that are available. But it's not only if it's flexible or rigid; it's also because of the properties that I will talk later. Regarding the monomaterial and complex and multi-layered is very important because when you are using a monomaterial with only one material, the properties are only related to that. So, but when you have a capability of join different materials in a composite, on a very good mixture, or in a multi-layer system, you are able to improve the properties of these materials. So, one of the examples is I think everyone knows, is a Tetra Pak. So in Tetra Pak, that are used in milk and other beverages, they develop a material that is very good as a barrier. So because they have aluminum foil inside, but they have different layers. So they have paper, they have plastics, they have aluminum foil, and with that they have different requirements that are uh, assessed, or they are able to achieve because they are using this multi-layer system. So it's very interesting. So, and right now, when you go to a plastic material, if you want to go to a high barrier, like for modified atmospheric packaging, as for meat, you are talking about 9 layers, 12 layers of plastic, of different plastic. So you can have like 4, 5 different materials, but they are then put all together in different ways. And these allow us and allow the industry to achieve very low permeabilities with a very thin film. So we are talking about 100 micrometers or lower. So it's quite interesting the way that the industry developed these kind of technologies, and they are in the market. So I will talk a little bit about these 5 types of packaging materials: glass, metal, paper, plastic, and bio-based and biodegradable materials. Um, we work mostly with paper, plastic, and bio-based and biodegradable materials. So I don't work with glass and metal, but I think that is important for you that are listening to the class. And if you don't have so many experience in these packaging materials, to have a look on the materials that we are using in the industry. So and some of the drawbacks and advantages of using each of these ones. So the glass is the result of the fusion of various raw materials, that when are cooled becomes a product. It's very hard, transparent, homogeneous, and stable. Is amorphous. It's amorphous materials, and consists of three basic elements: silica, calcium, sodium. So, is a material that has been used for years and still is very used. The only, and you can say one of the only drawback is because it's breakable in the because of the weight. Because when you go to the pros, it's very interesting, the glass, because it's inert, transparent. You can combine some materials and be colored because the incidence of light in some products is a very good barrier. You can do it in the different shapes. Is reusable and recyclable. This is very important in the nowadays. So glass is a very good materials. You have here quite an image with composition depending of type of glass. That is not so important, but can give you an idea of the main materials used in the glass production. Regarding the metal, there are different metals used in the industry. You have steel, aluminum, tin, and chromium, and it's also been used for years and is still very used. One of the key innovations in metal packaging is the easy open systems that we have right now. The reducing of the thickness of the metal sheet without decreasing the mechanical strength of the can, replacing the conventional solder by electrode soldering, the printing quality that was improved, and also the improvements of some coatings that it put inside to avoid the migration for the foods. So it's also important to have materials that don't have the migration of their components for foods, and then that should be avoided because in the end we will be heating some of these compounds. These are the constituents of the thin plate. It's a laminated structure as well. It consists of steel sheet uh, coated with the thin on both sides, and the thickness is is also quite low. So it's this kind of thin plate or this packaging that you use like in some tuna and so on. So there is very used and also used for foods that have a very high shelf life. So in the tin plate, the base steel is responsible for the mechanical characteristics and resistant to corrosion. That is very important because when you're putting different foods with different pH, this is one of the key points. The thickness is related to the mechanical characteristics of the sheet and closing of the can's dimensions. And with the change with the type of thermal processing, transport, and distribution. Tempering is a designation of the mechanical property of steel that is normally associated with hardness. So when you talk about tempering in metal, is related to that. Tin plating rate depends on the resistiveness of the product and the consequent tendency to corrosion. So this is, as I mentioned, depending of the food, this can be can be very important in this thin plate. So they can receive electrochemical passivation treatment. So it's these kind of layers that can improve the quality of these materials. So you also have the trim-free steel that in this case, the most difference is because it's very resistant to sulfidation and can provide protection and compatibility with a larger number of food products of low acidity. So this is also very important. So the aluminium is a no-ferrous material, very light, easy to make, and good resistant to atmospheric oxidation. Is only the most problem is the high cost to the energy expended in the production. When used for food contact materials, as a food contact material, is used in the alloy form. So and combined with different elements. Improves mechanical corrosion resistant characteristics. So normally we would need to have aluminium, very thin layer of aluminium to improve the properties. You have also some varnishes, like the organic coating, and is used to minimize interaction of the metals with the products. There are different resins, thermoplastics, or thermosettings, pigments, additives, and other kind of solvents. And they can have different colors. or be transparent, opaque. So this kind of varnish is also very used in the metal based packaging. So here are some advantages and pros and cons. So the metal steel base is chemical resistant with the product, corrosion and sulfidation, is resistant to low and high temperatures, good mechanical strength, possibility of decoration, very good barrier, and is recyclable and easy waste separation. So it's easy to make this recycling of these products. Have the problems is high opacity. So when you buy something like this, you are not able to see the product, and it's something, some products is important for consumers, and the reuse is limited. Aluminum base is very close to the one before, is resistant, very good barrier, and resistant to sulfidation and moderate corrosion. Both are can be flexible, rigid, and can be combined with paper and plastic, laminated. As I show you, the aluminum are using Tetra Pak with paper and plastic. Is recyclable, but has a very high production cost. Here in the plastic, so regarding the glass and metal, so the plastics, you should know, so the plastics, everyone is talking about plastics because of the problems that are bringing to the environment and for the sustainability issues that they can bring. They can be based on synthetic or modified natural polymers, which can be molded by heat under pressure. Are thermoplastics or thermosets, and the properties are determined by the chemical and physical nature of the polymers, molecular weight, degree of crystallinity, chemical composition using their manufacturer. So I will talk a little bit about the properties, and mostly of the, here the chemical composition is very important, but in the end, for the industrial production, the thermal properties are one of the most important properties in the plastics. Here are some of the materials that are being used. So you can see these numbers and acronyms of some of the materials that you can see in some of the packages that you buy. Some polyethylene terephthalate, that is PET, high density polyethylene, polyvinyl chloride, low density polyethylene, polypropylene, polystyrene, and other plastics. But maybe PET and polyethylene, as PP and PS are the most used and most well known, but low density polyethylene and PET are very used in food industry. And other of the materials are some barriers like ethyl vinyl alcohol that are used as a high barrier coating between these materials and using multi-layers. So what are the main advantages of plastics? Are light, unbreakable, recyclable. Depending if they are multi-layers, can be very difficult to make the recyclability of the material, and the possible combination paper and aluminum and other plastics. One of the points that is not here is the price. The price is very low at this moment for the petroleum-based plastics. Because for the biodegradable or natural base, the prices can increase a little bit. Some of the problems is the relative strength, but you can modulate that with different materials. The relative barrier that you also can improve, inertness, thermal resistance, and is impossible to reuse. So this reuse is also important because if it's not reusable, you need to go to recyclability of the materials. Regarding the paper is also very interesting. Paper is based on cellulose fiber, so is in fact is bio-based. Is dependent, the quality is dependent on the nature of the fibers. So you have short fibers and long fibers, and based on that, you can use it for different applications. When you want to offer some resistance to paper packaging, use long fibers. When you want to have some quality flexibility for printing, the short fibers from eucalyptus. So depending of the source, you can have different applications. The difference between paper and paperboard are mostly related with weight and thickness. Paperboard is thicker and heavier than the paper, and generally difference are the uh, the thick paperboard that is more than around 300 millimeters, and the weight can vary according with the grammage from gram per square meter. Some of the good things from paper is the different shapes and thickness that can be used. The combination with various materials to form laminates or coated products are resistant to low temperatures. That is also important because in some cases the plastics and other materials are not so resistant, and paper is. Have good printing properties, low weight, and is recyclable. One of the problems from paper is the low mechanical resistance, depending of the way that you are making these measurements, but normally is low. The low barrier property, so is not good related with avoiding the permeability of oxygen and water, and in most of the cases is not so water resistant. So have the paper, if you have water, the paper will dissolve if if a coating or some protection is not applied for the, or a treatment is applied to the surface of the paper. And then you have the bio-based, biodegradable, also edible materials. You can have raw materials from non-renewable and renewable, as we mentioned, and then you can say that you have different generation of the packaging, and that is increasing biodegradability according with the amounts of natural and biodegradable materials that you are adding for the synthetic ones. But the composites are not so, the focus is not use a mixture of biodegradable with no biodegradable, is to use all biodegradable. And so we are right now working on a 3 generation, only using bio-based and biodegradable polymers. In this fact, we can have different categories of products. So you have the one category that is materials that is directly extracted from biomass, such starch, cellulose, or chitin, that are obtained from biomass and then used in packaging. Then you have some of the polymers that can be synthetic, or so they are synthesized through chemistry, but they are obtained from biomass, like polylactic acid, and the very used and very known right now, the biopolyethylene, one from PLA is obtained from corn, and BioP is obtained from sugar, from sugarcane, mostly in Brazil. And then you have the other from microorganisms like PHA or PHP. So there are 3 different categories. You have here some examples from the direct extract from biomass. You have different materials that you can, lipids, polysaccharides, proteins, and also from the production of microorganisms, you have different like bacterial cellulose, also some proteins, and some of the polymers that can be used. We also have other kind of biodegradable packaging that are based on petroleum, so they are synthetic, but they are biodegradable, and they also are being tested and used by the industry, and because the price are low, they are more advantageous regarding some of the other based on bio-based sources. So other of materials that can be used, and I'm finishing, only more 5 minutes I can, and I will finish. So other of materials that we can use in these packaging materials, and that have been proposed as one of the ways to improve, to reduce the number of multi-layers that we are using, and to use more monolayers, because we will improve the recyclability of materials, are nanomaterials. Nanomaterials are, you can have different types. So you have the particles, dot clusters, 0D, nanotubes, nanocrystals, thin films, and aggregates and bulk crystals are 3D nanomaterials. So these are some of the materials that are used in packaging. And depending of the definition, you can use a nanomaterial based on European Commission recommendation. Mostly of the materials are based on size. But also FDA in the United States are saying that despite having more than 100 nanometers and you can reach 1 micron, you can have some of the properties that are related with the size and can be compared with nanomaterial. So these are one definition, is the definition from the European Commission that we are following, but it's very important to know that you cannot, if you can have similar properties of a nanomaterial uh, with higher sizes. It can happen depending of the property that you are trying to reach. But regarding the definition of European Commission, so consists of the particles with one or more external dimension in the size of a range of between 1 and 10 nanometers for more than 1% of their number size distribution, presents internal or surface structures in one or more dimensions in the size of a range of 1 nanometer and 100 nanometers, and has a specific surface area by volume greater than 60, excluding materials consisting of particles with a size lower than 1 nanometer. So this is the definition of nanomaterial for the European Union. And they are also being very used in reinforced packaging, active packaging, and intelligent packaging for different with different aims. So in reinforced packaging, high barrier capacity, better mechanical properties, thermal stability, UV blocking, and in case of active and intelligent packaging that I will talk a little bit more tomorrow, they can be used for antimicrobial activities, scavenging capacity, release of nutrients, and in intelligent packaging, detection of foodborne pathogens, detection of gases and chemicals, time and temperature monitoring, and control release of active compounds. So this is, in fact, you can have these different uh, type of packaging materials, or like reinforced packaging, active packaging, intelligent packaging, without using nanomaterials. But what we are seeing is that nanomaterials can help us in developing these kind of packaging systems. Some examples of nanomaterials are silver, zinc, silicates, nanoparticles, cellulose, nanocrystals, nanofibers, and also nano multilayers that can be used. One of the examples that I want to show you is how they can affect the permeability. So this is one of the examples. So in the imagine figure A, you can see a normal film. So you have the gas molecule that are passing through the film. And if you have some nanomaterial in the film, that is case B, you can increase the tortuosity of the film, and so the gas molecules have more difficult to go through this film. So you are decreasing permeability. This is because most of nanomaterials that are used on this case, such as nanocrystals, cellulose nanocrystals, nanoclays, are very crystalline and are not permeable to these molecules. So they are not able to pass through these nanomaterials. So they are more difficult to go through the film. And the other case, that is the case of image C, you can see how a multilayer can work. So you can have a very thin layer inside with a very low permeability. So you are increasing the time, or you are decreasing the diffusion path in the film, and you are decreasing the permeability. I will talk a little bit about permeability tomorrow, and then I can explain a little bit how it works, because it's not only the diffusion, but also other properties like absorption and solubility of the materials of the gases in the materials that can also be very important in the permeability aspects. So for today, I'm finished. I think that will be interesting for you I can share with you, I can send you this paper is food packaging roles, materials, and environment issues. It's 2007, but I think that can be interesting for the ones that want to start working with food packaging, to learn a little bit about the materials, but also about the sustainability of materials and the recyclability. Because I think before starting developing new materials, you need to know how it works and how it goes to maintain, in fact, sustainability of them. So thank you all for your attention. I think that we can have some minutes of questions right now, and I'm looking forward to know your doubts and questions and ideas about this. Thank you very much.